Let's take a look at exercise 11 from section 8.3. A person rowed her boat upstream a distance of 20 miles and then rowed back to the starting point. The total time of the trip was 12 hours. If the rate of the current was 4 miles per hour, find the average speed of the boat in still water. Boat speed and boat rate are the same thing, and we want to know what to let our variable represent. Typically in our application problems, what you're trying to find can be represented by your variable. There are a few exceptions to this rule, but for our problems, this is the general case. So if we're showing work for the problem, the first thing we want to show is that x represents the average speed of the boat in still water. We need to understand that upstream means the boat is traveling against the current. The current slows the boat down. Implied in the problem is the fact that when the boat returns, it travels downstream. So we need to understand that downstream means the boat is traveling with the current, which means the current speeds the boat up. So we're going to take this problem and divide it into two parts. And we can use a table to concisely show our information. One important part of the trip is everything related to the upstream part of the trip, and then everything related to the downstream part of the trip. And whenever we're dealing with motion, we need to understand that rate times time equals distance. This is a formula that you do need to know. So whenever you're dealing with motion, these are three important quantities: distance, rate, and time. We're going to start in our table by writing the distance. The problem tells us that the upstream distance was 20 miles. We will therefore assume that that was also the downstream distance, the distance of the return trip. Then we're going to talk about rate. If there was no current, the boat would be traveling X miles per hour. But since the upstream trip is when the boat works in opposition to the current actually slows the boat down. And instead of the boat's rate being X miles per hour, it's actually X minus 4 miles per hour. So it's traveling at a slower rate on the upstream portion of the trip. When the boat goes downstream, the current speeds the boat up, so it travels at the faster rate of X plus 4 miles per hour. Since rate times time is distance, if we solve that equation, that motion equation for time, by dividing both sides of the equation by r, we find out that time equals distance divided by rate. So the time of the upstream trip is 20 distance divided by x minus 4, the rate. The downstream time is 20 divided by x plus 4. So in both cases, we divide the distance of that portion of the trip by the rate. The problem told us the total time of the trip was 12 hours. So the upstream time added to the downstream time equals to 12. So this is a rational equation. Whenever we solve rational equations, we discussed this earlier in the course, we have to look at restrictions. We have to leave out values of x that will make either denominator 0. So x can't be 4 because that makes the first denominator 0. X can't be negative 4 because that makes the second denominator 0. So if either of these values shows up as a possible solution, they have to be rejected. Our LCD is the product of our two denominators, x minus 4 times x plus 4. These are completely different factors that have no common factors. So I multiply the LCD by the first term of the equation, by the second term of the equation, and also by the third term of the equation, which is the 12 that's on the right side of the equals. And when I multiply the LCD by the first term, the x minus 4's divide out. The LCD is in the numerator, x minus 4 is the denominator of that first term. When I multiply it in the second position, the x plus 4's divide out. So I'm left with 20 times x plus 4 plus 20 times x minus 4 equals 12 times x minus 4 plus times x plus 4. And notice I can multiply in any order, so I move the 12 to be the first factor in the product on the right side of the equals. Multiplying out, I get 20 times x plus 4 plus 20 times x minus 4. And I'm going to multiply on the right side of the equals x minus 4 times x plus 4 to get x squared minus 16. I'm going to add the common factors, 20x plus 20x to get 40x. 80 minus 80 is 0. 12 times x squared minus 16 is 12x squared minus 192. To get this in standard form, I need to subtract 40x from both sides of the equation, leaving me with 0 on the left equals 12x squared minus 40x minus 192. And equality is reflexive, which means I can make the left side the right side and vice versa. So I put the trinomial on the left side of the equation. Most people feel more comfortable that way. Whenever an equation, every term in the equation has a factor that's common, I can divide that factor right out of the problem and get an equivalent equation that has smaller coefficients. So 3x squared minus 10x minus 48 equals 0 has the same solutions as 12x squared minus 40x minus 192 equals 0. Factoring, since 3 is prime, the first factor in each binomial, one factor is 3x, the other is x. 48 has several pairs of factors, 1 and 48, 2 and 24, 3 and 16, 6 and 8, and I think that's all of them. I may have left some out, but the 6 and 8 are the ones, two factors that I want to use. And I have to have one negative and the other positive in order for that product to give a negative 48. So the 8 is positive, and with the 3x, the 6 is negative, and with the x. And I want to check to make sure that that really multiplies to give me that trinomial on the left side. So using the distributive property twice, also known as FOIL, I get 3x squared minus 18x plus 8x minus 48, which simplifies to 3x squared minus 10x minus 48. So that is the expression that I was factoring. So these are the correct factors. I set each factor containing the variable equal to 0. I get x equals negative 8/3, which is not applicable since the boat's rate is not going to be negative. And x minus 6 equals 0 gives me x equals 6. That is totally applicable. The boat speed in still water is 6 miles per hour.